Alrighty, let's kind of get going today so we can get to the classwork and the homework. Um, so today we're going to learn about something called a square root method, which is a way of solving a quadratic. What I do want to do before we do that is I want to back up really quickly. If I give you a quadratic in standard form, and I say solve it, what am I asking you to do? I'll give you an example. No, because if I wanted the vertex, I would say find the vertex. Okay? If I give you a quadratic in standard form, what am I asking you to do if I say solve it? Shh, wait, Sydney. Sort of. Not for this one. Yeah, but that doesn't tell me what I'm actually doing. Sydney said find the zeros, and she was very close. The only problem is this is not equal to 0. So finding the zeros is going to do nothing. The very first thing you are to do, let me back up. What I'm really asking you to find, I'm asking you to find the value or values of x that makes this true. It's an equation. I'm asking you to find the value or the values of x that make this true. Most of you do not have the ability to do that just looking at it. So what we did is we gave you a method for solving this equation. First thing you would do is you would set it equal to 0 by adding 7 to both sides, which gives you x squared plus 7x plus 10 equals 0. Again, most of you still couldn't find the values of x that make it true. However, now it's equal to 0, so you can find the zeros. If you were to factor this quadratic, you end up with x plus 5, x plus 2 equals 0. This we can solve, right? Because x equals -5 and x equals -2. And I want to be real clear about this. If you were to take -5 or -2 and you were to plug them in here, watch what happens. What is -5 squared? Not in your lifetime, Danny. It's 25. Thank you. What's -5 times 7? What is 25 minus 35? Plus 3? Right. You found the values of x that made the very first part of your equation true. That's what you did. It's a simpler way of solving the equation. Now, if it's a linear equation, doesn't have the x squared, it's not that big of a deal. Most of you can solve a linear equation, no problem. You just do all your algebra skills that you've been doing since 6th grade, and it's done. But when we get into x squared functions, it becomes a different deal. What we are doing, guys, and have since Friday, is teaching you a method of solving a quadratic equation. If I give you a graph of a quadratic equation, where do you look to find the solutions? The x-intercepts. You look for the x-intercepts. If I give you a table, you look where the y value is 0. Whenever we first started multiplying polynomials, I showed you 3 ways to multiply polynomials. You had the box method, double distributive, and the FOIL method. Then whenever we did factoring, which is working backwards, I showed you the box method and grouping, right? You are going to learn multiple ways of solving a quadratic. This way, the factoring thing is just way number 1. Square root method, which you're going to learn today, is way number 2. Tomorrow you're going to learn way number 3. Wednesday and Thursdays, ways number 4 and 5. You're going to learn a bunch of different ways to solve quadratics. But I need you understanding what it is that we're doing. You're not just going home and doing these freaking worksheets. You're learning different ways of solving equations, right? Because that's really what math is about, especially in high school. So let's get into what this is. Let's start with this. What squared is 36? That's half, right? And I'll tell you why. Up until this point, every time you've ever told me that the square root of 4 is 2, you've been half right. Because every square root actually has 2 numbers, 2 solutions. Because -6 times -6 is 36, and 6 times 6 is 36. This symbol means plus or minus. It's two numbers. The symbol makes that two different numbers. It's positive 6 and it's negative 6, plus or minus 6. Now, what I need you to understand is algebraically, when I give you an equation like this, what you really should do is undo the equation. If I gave you the equation x minus 3 equals 10, algebraically, what would you do to get x by itself? Add 3. If I gave you x divided by 5 equals 6, you would multiply by 5. Because it's the opposite, it's the inverse. What's the opposite of squaring something? Square rooting. So essentially what you are doing, guys, is you're doing this. Because the square root of x squared, the square root of anything squared is the anything. The square root of 4 squared, the square root of 4 squared is the same as the square root of 16, which just so happens to be 4. The square root of anything squared is anything, mathematically. Because it's two different things. It's like adding 1 and subtracting 1. You get back to where you began. Okay? So, like I said, algebraically speaking, on number 2, in order to get x by itself, I would simply take the square root of both sides. Square root of x squared is x. What's the square root of 100? Plus or minus 10. And that is your answer. Those are your answers. Two answers. From now on, every time you find the square root of something, you actually have two answers that you're going to give me. Unless it's the square root of 0, you're going to give me 2 answers. Okay? Square root of 0 only has 1. The rest of them all have 2. So here we go. Remember when we simplified improper irrational roots, right? You had to think about your list of all your square roots. Square root of 4, 9, 16, 25, etc. And I wanted you to split it. What's the split? Square root of what? Square root of what? 4 and 2. Remember, you want a good square root on the left. It needs to be the largest good square root that goes in. What's the square root of 4? Y'all are killing me. Plus or minus 2 square root of 2. Because the square root of 4 has 2 answers. Still, it did 5 minutes ago. It still does. Square root of 80 breaks down to the square root of 16 times the square root of 5, which is positive or negative 4 times the square root of 5. 2 answers. And square root of 25, square root of 6, positive or negative 5 times the square root of 6. Any questions on that? Yeah. The square root of 25 has 2 answers because 5 times 5 is 25 and negative 5 times negative 5 is 25. In fact, if you wanted to, you could tell me that this is 5 times the square root of 6 and negative 5 times the square root of 6. Both of them would be accurate. Okay? And it's because of this right here. Because the square root of 25 has 2 answers. Any questions on that? Okay, today we're going to learn about the square root method of solving a quadratic. I personally kind of dig this method because it's fast. It's much faster than factoring and setting equal to 0. There will be times where this is your simplest, easiest way to solve. It doesn't always work, but it works some of the time. So let's start with this. The square root property simply says that if x squared equals c, then what is the value of what is the value of x equal to? The square root of c or the negative square root of c. Because again, Danny, look, we would take the square root of both sides, right? Well, the square root of x squared is x. The square root of c has 2 answers. It's the positive square root of c or the negative square root of c. Okay? Always 2 answers from now on. So here we go. Number 1 says x squared equals 144. Now what you could do is you could subtract 144 from both sides, get it equal to 0. Then you could factor x squared minus 144 and get your solutions. Or you can simply do this. The square root of x squared is x. What's the square root of 144? Thank you, Kennedy. Plus or minus 12. And that is your answer. Those are your answers. By the way, those are two numbers. Make sure we're clear. Those are two numbers. Positive 12 and negative 12. So again, on number 2, I square root both sides. X equals positive or negative 1. You do 3 and 4, please. Or Dylan, you can find the square root of 196 by punching into the calculator that's sitting in front of you also, rather than waiting for me to write it on the board. Just throwing it out there. Okay, I know, that's true. I always have the answer. Okay, so let's get into something a little bit more complicated. So on number 5, we take the square root of both sides. So we end up with x equals, what is the square root of 50? It's an irrational root, so we have to do that thing. So the square root of 50 breaks down into the square root of 25 times the square root of 2. The square root of 25, positive or negative 5 root 2. Positive or negative 5 times the square root of 2. On number 6, our goal is to get x squared by itself. We want to isolate it. Now, here's an interesting thing. X squared minus 225 just so happens to be the difference of two squares. 225 is a perfect square. It's 15 times 15. So this is the difference of two squares, right? But I want you to watch. I want to give you a different way of solving it. If you added 225 to both sides, you would end up with x squared equals 225. You take the square root of both, you end up with x equals positive or negative 15. Now I want you to watch. If I said I want you to factor this as the difference of two perfect squares, what would your factors be? X plus 15, x minus 15. What would your solutions be to get those equal to 0? Positive or negative 15. You get the same answer. By the way, if you were to factor that, you'd get the same thing also. It's just a different way to solve it. That's all it is. Okay? On number 7, how would we get x squared by itself? What would we need to do to both sides? Spencer, ask your question.
Is it a non-perfect square?
We'll get to that in just a second. Not perfect. So here, you divide both sides by 5, right? These cancel. This gives us x squared equals 20. Square root, square root. The square root of 20 breaks down into the square root of 4, square root of 5, which is positive or negative 2 times the square root of 5, which is my answer. Positive or negative 2 times the square root of 5. Look at number 8. Now, theoretically, what you could do with number 8 is you could do x plus 7 times x plus 7. You could FOIL it. You could get a quadratic. It'd be x squared plus 14x plus 49 equals 9. Then you could subtract 9 from both sides. Then you could factor it. Then you could find your solutions. Or you can simply do this. Take the square root of both sides. What is the square root of x plus 7 squared? X plus 7. So you end up with x plus 7 equals positive or negative 3. Now, all we have to do to get the x by itself is do what to both sides? Subtract 7. Now, I want you to watch this. This is two different numbers. It's positive 3 and it's negative 3. So we have to account for both. What's positive 3 minus 7? It's negative 3 minus 7. Those are your answers. Those are your solutions. You have to consider both numbers. Try number 9 yourself. Any questions on that? You should have gotten 12 and negative 6. You take the square root of both sides. It gives you x minus 3 equals positive or negative 9. So then when you add 3 to both sides to get the x by itself, you have to do positive 9 plus 3 and negative 9 plus 3. Got it? Yes, that's no bueno. It's no good. Okay. Okay. Now, this is one you should probably watch because this one gets a little bit interesting. So, again, we do the square root to both sides. So we end up with x minus 2 equals the square root of 8. Now, the square root of 8 breaks down to the square root of 4 times the square root of 2. So it's positive or negative 2 root 2 plus or minus 2 root 2. Because that's what the square root of 8 is. I want to stop and make sure everyone knows where I got that number from. I took the square root of 8, split it into good square root, bad square root. The good square root became two numbers, because now we know that happens, and the bad square root stayed a bad square root. So now, to get the x by itself, we're going to add 2 to both sides. Now I want to show you how I want this written. Just like in a linear equation, there's an order that you'll see things, like the x terms are always before the constants. In a quadratic, we have the x squared guy, then the x guy, then the constant, right? When you write this, you would write it like this. X equals, this number would go first, 2 plus or minus 2 times the square root of 2. And that is your answer. Yeah, do you remember when we would subtract the number, subtract the x term, and I wanted you to write the x term first, way back in Unit 4? It's kind of the same thing. Now, I want to be real clear about this number. This is two different numbers. This is two different numbers. Sometimes you may end up with a test where the answer choices are decimals. How would you convert this into a decimal? Yes. You just punch it into this thing. If you were to type into your calculator 2 plus 2 square root 2 and hit enter, it'll tell you it's 4.83. If you were to then type in 2 minus 2 times the square root of 2 and hit enter, it'll tell you it's negative 0.83. They are two different numbers. This is an accurate way to write it. This is an estimation because it's irrational. Okay? The reason I'm telling you that is sometimes you may be taking a test where you do all this work and you look at your answer choices and they're all decimals. And you're like, crud. Well, you just take your answer and make it into a decimal. By the way, if you try to take your answer and make it into a decimal and you don't find your decimal, you have a problem. Okay? Which you need to fix. Try number 12. I do not want it as a decimal. Go slowly, take your time. Ease a few steps. I do not. I want it as a simplified root. Okay? Did anybody forget how to factor a number in your calculator? Okay, you go to y equals, you type in the number divided by x and go to the table. If you were to type in y equals 147 divided by x in your calculator and go to the table, you'll see this, 0 error. Then you're going to see 147. Then you're going to see 2 and like 73.5. Then you're going to see 3 and 49, right? If you go down the y side until you find a good square root, that is your guy. The calculator will factor for you. You just have to put it into y equals and go to the table. Now what that means, guys, is the square root of 147 breaks down to the square root of 49 times the square root of 3, correct? Which is positive or negative 7 times the square root of 3. So let's go back to our problem. We take the square root, the square root of x minus 10 squared is x minus 10. We already know the square root of 147 is plus or minus 7 times the square root of 3. So we're going to add 10 to both sides to get the x by itself. And we end up with x equals 10 plus or minus 7 times the square root of 3. And you can write it just like that. I want to pause and make sure everyone gets where I got all this stuff from. Any questions on that? Okay, one more quick thing, then I'll get you on your classwork homework. Look at number 13. Just watch me. I'm going to take the square root of both sides, correct? This becomes x plus 5. What does the square root of 6 become? 2 and 3, neither of which are good square roots. You can't break it down because the only good square root that goes into 6 is 1, and that doesn't do anything to it. So it just becomes plus or minus the square root of 6, stays just like that. So then when you subtract 5 from both sides, here's your answer. X equals negative 5 plus or minus the square root of 6. And that, peeps, is as far as you can go. Okay? Just take your time. Okay? Use the answer key. You have classwork and homework today, but it's like one page of each. There's nothing to it, but do the classwork first so that you know how I want your answers. Okay? Yes. What is today? Yes. Oh, today's the retake. No tutoring. Today's the Unit 8 retake. Don't forget.